Okay, in this section 7-4, our topic is parts of similar triangles. Okay, so there are two theorems that we're going to look at from this section. And the first one says this: if two triangles are similar, then the corresponding medians, altitudes, angle bisectors, and perimeters are proportional to the corresponding sides. Okay, so let's stop for just a minute and kind of frame this theorem, what it's saying here, for just a minute. Okay, in the previous sections when we learned about similar triangles, okay, we already knew that the corresponding sides were proportional. That's a part of the definition of being similar, right? In order to retain the same shape, the corresponding sides have to be proportional. We already knew that part. But what this theorem is saying is that it's not only limited to the corresponding sides, also the corresponding medians are proportional, the corresponding altitudes are proportional, the corresponding angle bisectors, and the corresponding perimeters are proportional to the corresponding sides. Okay, so what that means is that if you have any of these other pieces as well, medians, altitudes, angle bisectors, or even the perimeters, all three of the sides added together, then you can use those as one of your fractions in creating the proportion in order to solve for a missing side or a missing piece. Okay, so like for example, let's look at this. First of all, the corresponding medians are proportional. So what that means is if these two corresponding sides are, say, 8 and 12, then the medians, which remember from one of the units last semester, median starts at a vertex and hits the other side at the midpoint. If this median is 10 and this median is 15, then they're proportional because 12 over 8 is 1.5 and 15 over 10 is 1.5. So the corresponding medians are also proportional. So if this side got 1.5 times as big, then this median also has to get 1.5 times as big. So what we're saying is it's not only the matching sides that have to be proportional, but also the matching medians, altitudes, angle bisectors, and perimeters also have to be proportional. So that's kind of what we're saying here. All right, and likewise altitudes. So in other words, if this piece is 5, this piece is 10, twice as big. So if this altitude, which remember altitude starts at a vertex, hits the other side at 90 degrees, right? So that's why we put this in your notes to kind of review these terms if you've forgotten them. Okay, so if this side goes from 5 to 10, twice as big, then the altitude must go from 4 to 8, also twice as big. It's got to be by the same scale factor. Even angle bisector, which remember is cuts the angle in half. So if this side is 10, the matching side is 20, that's twice as big. If this angle bisector is 8, then the matching angle bisector also has to be twice as big, 16. So that's what that theorem is telling us. All right? Now, there's one more theorem, and it says this: if in any triangle, an angle bisector separates the opposite side into segments that are proportional to the two other sides. All right? So in any triangle, an angle bisector. So make sure you have an angle bisector first. Okay, so it cuts the angle in half. So you better know the degree measures are the same, or you must have the same number of marks or something to show that it's an angle bisector. Okay, so we have an angle bisector. So what happens? It separates the opposite side into segments that are proportional to the other two sides. All right, so this angle bisector will separate this opposite segment, right? Okay, or this opposite side into two segments that are proportional to these two sides. So if I make a fraction out of these two segments, 3 over 4, okay, it's got to be equal to, all right, the proportion made or the fraction made out of these other two sides, 6 over 8. Okay? So 3 over 4 equals 6 over 8. That's what the theorem is saying. Okay? So we're going to use these two theorems now to practice some problems. So the directions say the triangles are similar. Let's find the value for x. All right, so let's see what kind of proportion we can set up here. Okay, so I'll start with 12 right here, which is an altitude. So 12 matches x here. All right, so just to keep with scale factor, I'm still doing new over old. Now I'm going to set that equal to 13 over 6.5. Okay? So altitude to altitude and bottom side to bottom side. So there you go. So now I can go ahead and do my cross product. Let's see what we get. X times 13, of course, is 13x. 6.5 times 12 is going to be 78. Let's go ahead and divide it by 13. And we have x equals 6 is your answer. Okay, so there you go. What about the next one now when we set this one up? Okay, so on this one I've got two medians that should be matching pieces here. So let's go 20 over x. That'll be my first fraction. And I'm going to set that equal to 16 over 12. And once again, ready for cross product. 16x equals to 20 times 12, which is going to be 240. We're going to divide that by 16. And x equals 15 is our answer. Okay? So as long as you're getting your matching parts correctly sorted out when you're making your fractions, you should be fine. All right, next fraction, the first one I want to make is x matches with 8. X over 8 equals 12 over 10. Once again, we're ready for cross product. 10 times x equals to 8 times 12, 96. Let's divide it by 10. By 10, x equals 9.6 is the correct answer there. And we have one more which utilizes that second theorem that we had looked at. And so let's go ahead and see if we can create our proportion. And so when we do, it looks like this. So it'll be x over. Now, the reason why I have this circled on here is when you get to the problems on the quiz, this part is not going to be given to you. You're going to have to figure it out. And here's how you figure it out. If they give you this piece and this whole piece is 20, okay, the way that you're going to figure out what this piece is going to be is, think about it like this. Let's say that instead of being an x, this was a regular number like 8. Let's say the whole thing is 20 and this part is 8. What's the other piece? Well, remember, these two pieces have to add up to 20. So if this is 8, this would have to be 12. How'd you get that? 20 minus 8. Okay? What if it's 5? Okay? Well, then this one is 15. 20 minus 5. Okay? So here's the deal. If this is 8, the other piece is 20 minus 8. If this is 5, the other piece is 20 minus 5. If this is 13, the other piece is 20 minus 13. So if this is x, then the other piece is 20 minus x. So that's what I'm going to put as the bottom part of my fraction, 20 minus x. So like I say, the one on your quiz is going to have that missing, and you're going to have to come up with that expression in order to make your fraction. Does that make sense? So if the whole thing, it's the whole thing minus this piece equals the other piece. All right? And just make sure that you're not writing x over 20, because that's not correct. It's got to be this piece over this piece, not this piece over the whole thing. Okay? So these two pieces are proportional to the other two sides. So when I make my other fraction, it's going to be 18 over 30. So again, just make sure you go in the same direction. If you use top over bottom for this one, you got to use top over bottom for the other sides to keep it correct. All right, so now we need to go 30 times x and get 30x equals 20 times 18 is 360 minus 18x. So I'll go ahead and bring my 18x over. 30x plus 18x is equal to 360. So now I'm going to add those together. 48x is equal to 360. 48 48x x equals to 7.5. And that is your answer. So now you guys are ready for your quiz.